So a sequence is a list of numbers that follow a rule. A series is the sum of the sequence, so we're adding together all the terms in the sequence. So 2, 4, 6, 8 is a sequence. 2 plus 4 plus 6 plus 8 plus ... is a series. One way we can write series is using sigma notation. For a finite series, it would look like this. 2 plus 4 plus 6 plus 8 equals, and the E-looking thing is a capital Greek letter, sigma, hence the name sigma notation. The letter down at the bottom is called the index of summation. It's your variable. What it equals is called the lower limit. That's what we start with. And the top is called the upper limit. That's what you end with. And that is your rule for the nth term. That's your AN formula. If it's infinite, our upper limit is infinity instead of just a number. So write as a summation, 4 plus 8 plus 12 plus ... plus 100. So we need to figure out what our rule for the nth term is. So these are the ANs, and N's are 1, 2, 3. So notice if I take this N and I multiply them by 4, I get the AN. So 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and so on. Oh, if that's the case, then what times 4 makes 100? 25 times 4? So that means my rule is 4n. I'm taking the n's and I'm multiplying by 4. Lower limit is 1, upper limit is 25. So it looks like this. We have the sigma, choose some variable. I chose n. Our lower limit is 1, upper limit is 25, and our rule for our nth term, which is 4n. I'm just multiplying the value of n by 4 to get the an. Here, let's try this one. Again, I need a rule for an nth term. All right, and how did I get that? Well, let's see. If n is 1, 2, 3, 4, we could write this as 2 over 1. If we do that, it looks like the tops, the numerators, are just 1 more than n. So the top would be n plus 1. The bottom, this is 1 squared, 2 squared, 3 squared, 4 squared. So that is just my n squared on the bottom. So it's n plus 1 over n squared. Lower limit is 1, and because I start at 1 there, and since it goes ... upper limit is infinity. So it looks like that. Some variable, lower limit, upper limit, and our rule for the nth term. Note you can use any index, be any letter. I happen to use n. Here they use k. Find the sum of the series. Alright, so notice the lower limit is 5. That means I'm going to start by filling in a 5. So I filled in the 5. It's k squared plus 1. So it'll be 5 squared plus 1 plus, and then you do the next number, 6 squared plus 1. And then you do the next number, 7 squared plus 1. Then you do the next number, 8 squared plus 1, and 9 squared plus 1, and 10 squared plus 1. And we stop there because our upper limit is 10. So we filled in the number 10. The upper limit is what number you fill in, not how many terms you've done. So I started at 5, ended at 10. And you have to figure out what all those are. So, it's 5 squared plus 1 is 26, 37, 50, 65, 82, 101. Add those together, you get 361. So the sum is 361. Some shortcut formulas for finding sums. If I'm adding together ones, it's just n, because it would be 1 plus 1 plus 1 plus 1 plus 1 n times, so I have 1 times n. If I just add I, so that'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So this would be, let's write it out. It'd be 1 plus 2 plus 3 plus 4 plus 5. And this next one is squared, so it'd be 1 squared plus 2 squared plus 3 squared plus 4 squared, and so on. Those are just formulas to help you. You don't have to memorize them. So here's how we would use that. We could rewrite this as a couple different sums. So we could rewrite this as the sum of 3k squared plus the sum of 2. And then every time I'm adding the 3k squared, I'm always going to have this 3. So it'll be 3 1 squared. 3 times 2 squared, 3 times 3 squared. 3. I could factor out the 3. So this would become 3 times the sum of k squared. And 2 is the same as 2 times 1, and I'll have the 2 every turn. So I can have 2 times the sum of 1. That's a formula, and that's a formula. So here's the first formula for the squared. There's the formula for the 1. And notice the number in front, so it's 3 times the k squared formula plus 2 times the 1 formula. And then what do I fill in for the n? Well, that's going to be my n. The upper limit is my n, assuming that I start with 1. I have to have the lower limit as 1. So I fill in my 10, and I run it through my calculator. I get 1,175.